Let's do a quick exercise where we rewrite finite decimals as a decimal fraction. We'll need this skill in another video where we learn how to add two decimals, finite decimals, and to explain the algorithm, I'll be needing the skill. So let's practice this. So what do I have here for you? I have a decimal number. We recognize it's a decimal number or a finite decimal. It's the same thing. We recognize that this is one such decimal number because of the decimal point here. And we recall that this is simply an abbreviated notation for a fraction. In fact, for a fraction that has a power of 10 in the denominator. What power is that? From the abbreviated notation, we do remember that the number of zeros in the power of 10 matches with the number of decimal digits. Here we see that to the right of the decimal point are 3 digits. So we put 3 zeros here. And the original number in the numerator would just be this without the decimal point. So you rewrite all of the digits that you see here, just don't place the decimal point. So that is indeed the notation that we learned in another video. So to make this process quick and sort of mindless, once you understand what the notation is, this is what we can do. Whatever you see here, write it there. Don't write the decimal. Where you see the decimal, you can write a 1 in the denominator. And for each digit to the right of the decimal, 1, 2, 3, you put a 0. So let's do that for this one. Draw a fraction bar. Take that, write it as you see it. No decimal point, I don't put it. And where the decimal point was, I can just remember that and put a 1. And then for each of these digits, 1, 2, 3, 4. And double check. Number of zeros in the power of 10, 4, matches with number of decimal digits, also 4. This is really the Clavius's shorthand notation.